Good morning, students. Today we will derive the expression for work done or displacement work in a constant pressure or isothermal process. The condition for isothermal process is PV equal to constant, which means that when both product of pressure and volume is constant, then the process will be constant temperature process or isothermal process. We know the basic formula for work done in any thermodynamic process, or PdV work done in any thermodynamic process is W1 to 2 equal to integration of P into dV under the limits V1 and V2. We know the condition for isothermal process is PV equal to constant. Here this is the condition for isothermal process, PV equal to constant. This PV equal to C or PV equal to constant can be rewritten like this: P into V equal to P1 into V1, which is equal to P2 into V2, which is equal to constant. Now I will rewrite this equation. Then P equal to P1 V1 by C. Okay. Then now substitute the value of P in this equation. So if you substitute, you will get this equation. Okay. Now if you integrate this, dV is constant, integration constant. If you integrate 1 by V, then you will get log V under the limits V2 by V1. If you rewrite this equation, it becomes P1 into V1 ln of V2 by V1 or log V2 by V1. This equation I can again rewrite like this: P1 into V1 ln of P1 by P2, because from this equation V2 by V1 equal to P1 by P2 I can rewrite. So again we know the ideal gas equation, which is PV equal to mRT. Then P1 V1 equal to mRT. Then substitute this value of P1 V1, which is mRT, in this equation. So it becomes mRT ln of V2 by V1 or mRT ln of P1 by P2. Okay, this is an expression for work done in isothermal or constant temperature process. Now we will derive an expression for work done in polytropic process. Polytropic process is any thermodynamic process or which represents any thermodynamic process which obeys this relation or which obeys this expression: PV equal to PV to the power n equal to constant, where n is polytropic index. Based on this polytropic index value n, it takes the different form. Let us try. If you put n equal to 0, it becomes P equal to C, which is isobaric process. If you put n equal to 1, which becomes PV equal to C, which is isothermal process. So like that, depends on the value of n, polytropic index value, it takes different thermodynamic process. It takes the form of different thermodynamic process. Now let us derive a general expression for work done for polytropic process. We know the relation PV to the power n, which is equal to P1 V1 to the power n, which is equal to P2 V2 to the power n, which is equal to constant. Now let us extract the value of P from the above expression. P equal to this expression. Now we know the general expression for work done. Work done in any thermodynamic process or PdV work done is, if you put that P value in that expression, it takes the form like this. As P1 V1 to the power n is constant, you can take it out of the integration sign. Okay, 1 by V1 is integrable form here. So if you integrate this 1 by V to the power n, it takes the form like this. Okay, apply the limits V1 and V2. So if you apply the limit, it takes the form. So this form it takes. If you simplify, it becomes like this. That finally the work done during polytropic processes or expression for polytropic processes W1 to 2 or work done in the process 1 to 2. Okay, which becomes P2 V2 minus P1 V1 divided by 1 minus n. Or I can rearrange this expression. I can also write like this: P1 V1 minus P2 V2 by n minus 1. So this is a general expression for work done in case of polytropic process which obeys the relation PV to the power n, which is equal to C.